we have log of base 9, 81 equals 2. So we have to go from logarithmic to exponential. Okay, so we have to know what the a is, what the x is, and what the y is. In this case, my a will be 9. My x will be 81, and my y is 2. So it's going to be a, which is 9 squared, equals 81. Again, that's my a, that's my y, and that's my x is 81. So this is a conversion. Now we're going to go the other way around. We're going to write each exponential equation into a logarithmic equation. So we have 5 cubed equals to 125. So again, we have to know what the a is, what the y is, and what the x is. My a will be what, 5, my y will be 3, and my x will be 125. So it's going to be y is going to be 3 equals to log of base 5 of 125, or log of base 5 of 125 equals 3. I believe these two examples are very self-explanatory. For each, for each conversion, you have to know what the a, the x, and the y is. Okay. Now, in order to graph without a calculator, you must convert logarithmic equations into an exponential equation. Again, this is review exponential functions. So this is an exponential function. To graph it, right? These are all the examples of exponential functions. Why? Because the exponent is a variable. The a is like the base, and the letter is called a variable. Okay. Now let's graph f of x equals to 2 to the x power. Remember, guys, that when graphing exponential logarithmic functions, we always use the values -2, -1, 0, 1, 2, and 3. In this case, we're going to plug them in for x. So let's draw ourselves a little table. Right, so we start with x equals -2. So I'm going to go to my function. I'm going to evaluate f of -2, which means I'm going to plug in -2 for the x's. Now, 2 to a -2, by applying the rule, is going to be 1 over 2 squared. So what you give us 1/4. So when x is -2, y is 1/4. Now let's evaluate f of -1. When x is -1, all we do is plug in -1 for the x's on the function, and we just simplify. This will give us 1 over 2 to the first power, which will equal to 1/2. So when x is -1, my y, or my f of x, is equal to 1/2. Now let's see what happens when x equals to 0. F of 0 means that we're going to plug in 0 for the x's. Now anything to a 0 power is always 1. Okay, so this will give us 1. So when x is 0, my f of x, or my y, is equal to 1. Now let's try 1. We're going to evaluate f of 1, which means we're going to plug in 1 for the x's on the original function. 2 to the first power will give us 2. So when x is 1, my y is 2. Now let's evaluate f of 2. Again, we're going to plug in 2 for the x's on the original function. It's going to give us 2 squared, will give us 4. So when x is 2, my y is 4. Finally, we have to evaluate when x equals to 3. So f of 3, which means, again, I'm going to go back to the original function, and I'm going to plug in 3 for the x's. That will give us 8, because 2 times 2 times 2 is 8. So we got our points. So this is my graph. Every exponential function, this is called like the parent graph. Okay, it will always take this shape on the graph, as long as the base is more than 1. This will be the actual graph, something like this. Okay. Now let's do logarithmic functions. Okay, again, in order to graph without a calculator, you must convert the logarithmic equation to an exponential equation. So remember, this is a conversion. Let's graph y equals to log of base 2 of x. So this is going to give us 2 to the y equals x. Now, but instead of plugging in the values for x, we're going to plug them in for y. Okay, because if we plug them in for x, it will be kind of complicated to solve for y, which we can, but that's by using the ln function, which will give us, we have to do a lot more work. So that's why we plug him into y. Again, if we plug him into y, the same process occurs like the previous slide, right? But we plug him into x, but we get the same result. So this will be my result if we plug in the values for y, right? This will be the values for x. Now, the graph for the exponential function, right, is in blue, and the graph for the logarithmic function will be in red. Let me show you why these are my points here. Okay, if x is 1/4, it means that from 0 to 1, I'm going to cut it into 4 equal parts. So 1/4 will be about between 0 and 1/2, and if we go all the way down, it's going to give us -2. When x is 1/2, right, is right in the middle between 0 and 1, so 1/2 will give us -1. When x is 1, my y is 0. When x is 2, my y is 1. When x is 4, my y is 2. And when x is 8, my y is 3. So this graph will continue, steadily increasing all the way to infinity. Okay? But this is a review of what we did last week. Now comes this week's lesson, which is solving exponential equations and solving logarithmic equations. So let's start by solving exponential equations. Okay, now this is what you gotta know. To solve exponential equations without a calculator, you need to know previous topics such as perfect squares. 4 is a perfect square because 2 squared is equal to 4. So all these numbers on the right are perfect squares. So you have to know as many as you can, at least from 1 to 100. Okay, and these are perfect cubes. All these on the right are perfect cubes because 2 cubed is equal to 8, and the cube root of 8 is equal to 2. Okay. Now the perfect fourth roots, 16 is a perfect fourth root, so is 81, so is 256, and so is 625. These are the perfect fourth roots. Also, you need to know exponential expressions. For example, a to the m is called the base, and m is called the exponent. You also have to know the exponent power rule. If you have a base raised to a power raised to another power, you multiply the powers. And also you must know how to solve at least one variable equations. For example, something like 2x plus 8 equals to 14. So all these topics you got to know before we start solving exponential equations. Okay, now, this is the first property here. It says let a be a positive real number with a cannot equal to 1. Okay, so here's the rule. If a to the u equals a to the v, in other words, if they have the same base on both sides, then the exponents must equal to each other. Then u must equal to v. Example, you have 3 to the x equals 3 to the fifth. If you notice, these have the same base. So once you have the same base, then you can apply the rule. So x must equal to 5. That's my answer. I started out with something very basic and simple just so you know how to apply the rule. Now, how about this one here? Example 6. We have x to the 6 equals a to the x equals, example 6, a to the x equals 2 to the fifth power. These are not the same base, right? They're not the same bases. So in other words, we have to make them the same base. If we know, right, 8 is a perfect, 8 can be reduced to 2 to the third power, right? 8 equals 2 to the third power. So I'm going to replace 8 with a power of 2 to the third, right? Then the left side stays how it is. Now here is where I'm going to apply the power rule. When you have a base to a power base to another power, we multiply the powers. Right, so 2 to the 3, 2 cubed to the x power will give us 2 to the 3x. The right side stays how it is. Now we can apply the rule because we have the same base. So that'll give us that 3x equals to 5. We divide both sides by 3, and x equals to 5 over 3. The good thing about these is that we can always check our work. Okay? So then let's go back to the original equation, which is 8x equals to 2 to the fifth power. I'm going to plug in 5/3 for x. Right, we're going to plug into the calculator. Remember, guys, a to the 5/3. Most of the times, the exponent must be put into a parentheses. Why? Because it's a fraction. So in this case, if we put the a to the power of 5 divided by 3, it's going to give us 32. So we know these are equal. Now this is applying the fractional exponent rule. If you have a to the m divided by n, right, as a power, the denominator becomes your index. The a is a radicand and the m is the exponent. Okay, so let's apply that. Let's apply this rule here on the right. Right, so the 8 is a radicand, which is a base. The 3 is my index, and the 5 is my exponent. Now, what's the cube root of 8? The cube root of 8 is equal to 2. Right, so 2 to the 5th power equals to 2 to the 5th power here, so you can check it. Most students, they don't know about this rule here. This rule is very important, especially if you have to take the other math course, which is a 1325. Okay, so you have to know that rule. Okay, but this is how you can check your work with or without a calculator. Solving exponential function equations to continue. Example 7. We have 9 to the x power equals 27. Here, guys, let's see if we have 9 to a power will give me 27. You see, because they're not the same base. So we know that 9 squared equals 81 is not 27. So we have to lower down both the 9 to the x and 27 with a common base. The common base is going to be 3. Why? Because 9 equals to 3 squared and 27 equals to 3 cubed. So now I'm going to replace 9 with 3 squared and just put the exponent. Then I'm going to replace 27 with 3 cubed. Now here on the left, I'm going to apply the power rule or the exponent power rule. Right? Again, when you have a power to a power, you multiply the power. So they will give us 3 to the 2x equals to 3 to the 3rd power. Now we have the same base, which means we apply the rule. Right? When you have the same base, the exponents must equal to each other. So 2x equals to 3. Now we can divide both sides by 2, and the answer will be 3 over 2. And again, we can always check our work. Right, so I'm going to plug in 3 halves for the x. Now this one you can do it with a calculator or without. So if we put in the calculator, it's going to give us 27 on the left side, and it's equal to 27 on the right side. So I know that's my solution. Hey guys, as I'm doing the presentation, if you guys have any questions at all, you can stop me, and because even though I'm sharing my screen, I'm in my other computer. I'm here at the office, so I can see if you guys have a question, and this way I can answer your feedback right there and then. Okay. So let's continue. This one gets a little bit more challenging, right? We have example 8. We have 4 raised to the power of x minus 1 equals to 32. And again, let's see if 4 and 32, if 4 is a base of 32, right? We know that 4 squared is equal to 16, right? It's not 32. Let's try 4 cubed. It's 64. So I know that 4 is not a base of 32. So then let's try another base. Let's try 2. Find the common base between 4 and 32. 4 is 2 squared, and 32 is 2 to the 5th power. So then again, we're going to substitute 2 squared for the 4, bring down the exponent. And now, so we're going to replace the 32 with 2 to the 5th power. Now, we're going to apply the exponent power rule. Again, when you have a power raised to a power, we multiply the powers. So now we got the same base. So we let the exponents equal to each other. We're going to distribute. So we got 2x minus 2 equals to 5. We add 2 to both sides. So 2x equals to 7. We divide both sides by 2. So x equals to 7 over 2. Again, we can always check our work. So let's plug in 7 over 2 for the x. 7 over 2 minus 1 will give us 5 over 2. Now again, 4 to the 5 halves, we can plug it into the calculator or apply that going from exponent to radical. But here, guys, all we do is plug into the calculator, so it is going to give us 32. And you can always check your work as we go along. So 32 on the left side, 32 on the right side, so we know that's my solution. Now, I believe that's plenty of examples for the solving with the same base. Now let's solve logarithmic and exponential equations. You need to know previous properties such that. So these are the properties that you need to know for to solve logarithmic and exponential equations. We need to know some of these properties. Okay, now this is called a product rule. Why? Because if you have log a base a times x times y equals to log a base a of x plus log a base a of y. The left side is called single log or condensed, and the right side of the equal sign is called expanded. So this is rule number 2, which is a quotient rule. If you have log of base a of x divided by y, it equals to log of base a of x minus log of base a of y. Again, when you multiply them, the product, we're going to add them. When we divide, we're going to subtract. And finally, the last one is called the power property. If you notice, on the left, we have log of base a of x to the r power. The exponent comes to the front. So it's equal to r log of base a of x. This is crucial to know because when we're trying to solve for an exponent, right? Say we have an exponent an x on the exponent, we take the log or the ln and bring it to the front. The ln is called the natural log, which are on the right. You see, we apply the same properties. The ln of x times y is equal to the ln of x plus the ln of y. The ln of x divided by y is equal to the ln of x minus the ln of y. And here's for the power property, right? You have ln of x to the r comes to the front. So it's equal to r ln of x. Hey guys, remember the example that we did earlier? That it was 9 to the x equals to 27. And remember that we have to find the same base. Well, not every time, if you don't want to, you don't have to find the same base. It depends on your instructor if he wants you to find the same base on your exams or stuff, but it's up to them. I let my students have the choice how they want to solve it by getting the same base or by using the ln. So this is a recap, or like let's recall example 7, right? This was my answer. Solving by using the power property of natural log. So we're going to solve it another way. Okay, so here it is. So to do it by taking the ln, we have to bring down the exponent, right? So we're going to take the ln on both sides. Now we apply the power property. By rule is when you have the ln, like here on the right, the power goes to the front. Well, the exponent goes to the front, right? So this becomes x ln of 9 equal to ln of 27. Now we're going to divide both sides by the ln of 9. So x equals to ln of 27 divided by the ln of 9. And if you put that in the calculator, guys, it's going to give you 3 over 2. Get 1.5 or 3 over 2. You see, guys, we get the same thing. Most students like to use this property instead because they have a hard time trying to find the same base. Okay, like I say, you can do it either or. For my class. Okay, now, this is very important, okay? Because at times, the ln, right, has a number or a value. Like the ln of something is an actual value, it cannot separate them. For example, the ln of 9 is together, such that the ln of 27 is one number. And you can find what the number is by plugging into the calculator, okay? But most of the times, they're going to be asking you for your homework to round off to say 2 or 3 places at the end. That's why you don't round off until the very end, okay? This way, you get a more accurate decimal. And again, repeat, the ln of a number is an actual value. You cannot separate them. Okay, they're together. For example, you cannot divide both sides by the ln because that doesn't make sense. I mean, here has to be the ln of 9 of both sides. Okay, so please don't forget that. Now, this is a rule again, right? Then u and r are real numbers, with u being positive. Then the ln of u to the r equals to r ln of u. Remember, this is a third rule on the property that I showed earlier. The exponent goes to the front. Example, they always want you to see if you can find the same base. You see, but at times you cannot find the same base. That's why this property is crucial to know how to use. For example, say that they told you to find the same base here, guys. It's really impossible to, I mean, it's not possible to find the same base. So when that's the case, you can always apply the ln, the natural log. Okay. So here, guys, we're going to apply the natural log to both sides of the equal sign. I mean, you do it on the left, on both sides of the equal sign. So by rule, right, by the exponent property rule, or the power rule, the exponent goes to the front. Then we divide both sides by the ln of 5. And we plug into the calculator. So this is my solution, approximately 1.2920. Most of the times, they want you to round off to 4 places on your homework. Okay. Also, can we check our work? Of course we can. So x equals, right, approximately 1.2920. So we're going to plug that value in for x. And you're not going to get exactly 8. You're going to get a little bit under or a little bit over, but it's always rounds off. It's going to round off to 8. You see, this is my solution, right? 5 raised to the 1.2920 power gives you 7.99996, which eventually rounds up to 8. Now, this is the hardest it gets. Okay, this is example 10. It doesn't get any harder than this because this requires a lot of algebra. Okay, so let's do example 10. The ln of x plus 4 equals to 3 raised to the power of x plus 4 equals to 5 to the power of x minus 3. What's the value for x? So again, not the same base, cannot get them with the same base, so bring down the exponent by taking the ln of both sides. So we're going to take the ln of both sides. Now by rule, the exponent goes to the front. Right, so the exponent x plus 4 goes to the front, so we have x plus 4 ln of 3. On the right side, the exponent of x minus 3 goes to the front, so we have parentheses x minus 3 times ln of 5. Now we're going to distribute. So here, guys, it's going to give you the ln of 3 times x. I like to put the x in front. I mean the numbers in front. Why? Because if not, you have to put parentheses. So you always put the number in front to eliminate some of the confusion. Okay, so it's going to be the ln of 3 times x will give you x ln of 3. The ln of 3 times 4 will give you 4 ln of 3. On the right side, the ln of 5 times x will give you x ln of 5. And ln of 5 times negative 3 will give us negative 3 ln of 5. Okay, now we have to combine. I mean, we have to send all the terms with an x to one side, and the ones that doesn't have an x to the other side. It doesn't matter. But since x is always on the left side, so I'm going to subtract the x ln of 5 from both sides and subtract 4 ln of 3 to both sides. This way, I'll have every term on the left with an x. Okay, let me show you what I'm talking about here. Minus x ln of 5, minus x ln of 5. And at the same time, I'm going to send the 4 ln of 3 to the right side. Minus 4 ln of 3, minus 4 ln of 3. So we know, right? These cancel, right? Because that'll be 0, and that'll be 0. So what's left? X ln of 3 minus x ln of 5 on the left side. On the right side, we have 3 ln of 5 minus 4 ln of 3. So the reason why I want to send all the terms with an x to one side or the other side, because this way I can factor out the x because we're solving for x. So now what comes next is we're going to factor out an x on the left side. If we do that, it's going to give us x ln of 3 minus ln of 5. And you can always check your work, right? If you distribute the x, you're going to get that same thing as above. X ln of 3 and minus x ln of 5. So then we just bring down the right side. Now we're going to divide both sides by the ln of 3 minus ln of 5. Now this is my result. This is my exact answer. Okay, this is exact. I believe at times your My Math Lab will want the exact answer. And then they want you to round off, say, to 4 places. So this is my exact answer. And we use the calculator to see and put it in decimal form and round off to 4 places. This will be your answer, 18.0546. Okay, now, can we check our work? Sure, we can again, right? This is my original equation, so I'm going to plug in 18.0546 for both x's on both sides of the equal sign. So this will give us 3 to the power of 22.0546. And on the right side, it's going to give us 5 to the power of 15.0546. Because if we subtract 3, it's going to give us 15.0546. Now, if you put that in the calculator, it's going to give you something crazy, right? I mean, I believe it gives you something like 3.33206777810 times 10 to the 10th power. But anyway, guys, this is what it gives you on both sides if you plug them in. Because I did that work just recently. I added this problem just about an hour ago. Because this way, some instructors actually assign this one for homework. I mean, I do, and also I wanted to give you guys an example how to work it out. Okay, but anyway, you can always check your work, and they both check out on both sides of the equal sign. Now we're going to be solving logarithmic equations. Okay, so again, this is a property that we're going to be using. It says let u, v, and a be positive real numbers, with a cannot equal to 1. So if you have log of base a u equals to log of base a v, right? So if you have the same logs with the same base on both sides of the equal sign, then the u must equal to the v. That's a rule that we're going to be applying. Example, right? These have the same base, right? Because if there's no base, it's base 10, right? Single log with the same base, both sides, right? So we can apply the rule, right? This is base 10 on both sides. So then, by applying the rule, then x must equal to 3x minus 6. Now we're going to combine x's from, put the x's on the left side, so we're going to subtract 3x to both sides. So that gives us negative 2x equals to negative 6. We divide both sides by negative 2. So the answer will be x equals to 3. And again, we can always check our work. Right, so check the 3. So we're going to plug in 3 for every x, right, on both sides of the equal sign. So we're going to plug it in there. And also over here where it says 3x, we're going to plug in the 3. This gives us on the left side log of 3. On the right side, it will also give us log of 3. So we know that's my solution. Again, same property. Let's do another one. Now, example 12. You cannot apply the rule first, right? Because they have to be a single log on both sides. So, right, so this, we're going to be applying one of the properties, right? When you have a plus, right, we're going to multiply these by putting them together. Again, that's one of the properties that I believe section 4.3 covers. Anyway, again, right, we're going to put them as a single log because they have to be a single log on both sides. So again, we apply the property. Now we have the same logs on both sides with the same basis. So the x plus 3 must equal to x minus 2 times x plus 3. So now we're going to multiply the binomial, right? We're going to do the FOIL. That gives us x squared plus 3x minus 2x minus 6. Why? Because x times x will give us x squared. X times positive 3 will give us positive 3x. And negative 2 times x will give us negative 2x. And negative 2 times 3 will give us a negative 6. We combine like terms. This gives us x plus 3 equals to x squared plus x minus 6. Now, every time that you have something squared, we have to let it equal to 0 because we have to be able to factor. So I'm going to send the x and the 3 to the right side by subtracting x and subtracting 3 to both sides. So 0 equals to x squared minus 9. Now the x squared minus 9, to solve it, we're going to factor. That gives us x minus 3 times x plus 3, which means x equals to 3 and x equals to negative 3. Right? These are my solutions. Now let's check both solutions. Let's go to the next slide. Let's check them, right? So when x equals negative 3, we're going to plug in negative 3, right? This will give us log of 0 on the left, right? If you put on your calculator log of a negative number, it's going to give you undefined, not defined. If you plug in 0, if you put log of 0 or the ln of 0, it's also going to give you not defined or error message, which means the logs can never be negative nor 0, so they have to be more than 0, so they have to be positive. That's why negative 3 is not a solution. Okay. Now let's test the 3. Let's put 3 for every x. Let's give us log of 6. Logs, I mean, the base is 10, right? Because there's no base, so it's base 10. On the right side, we have log of 1 plus log of 6. Hey, guys, the log of 1 is equal to 0 if you put that on the calculator. So we know that log of 6 equals to log of 6. So that's my solution. Let me go back real quick. Again, so only the 3 is my solution. Now, again, we're applying the same rule. So example number 13. Remember when it was addition, right? Remember when it was addition, it was going to be, the product rule. Now what happens when it's subtraction? So it's going to be the quotient rule, because in order to apply the rule, you have to have single logs on both sides of the equal sign. So by applying the rule on the right, which is the quotient rule, right? When you have to put it as a single log, then this becomes your numerator, and the one with a minus becomes your denominator. So this is now equivalent to the log of x plus 3 minus the log of x minus 1, right? It's going to be as a single log. It's going to be log of base 10 of x plus 3 divided by x minus 1. Now we can apply the rule because we have single logs on both sides of the equal sign. So we know that x equals to x plus 3 over x minus 1. Here, guys, you can do it here several ways here, okay? For example, I believe what I did here, I cross multiply because there's there's supposed to be there's a 1 on the bottom here. So to cross multiply, I multiply x times x minus 1 and 1 times x plus 3. Or you can also multiply both sides by x minus 1, right, to get rid of the fraction here on the right. But anyway, guys, this is what it will give us. So we multiply both sides by x minus 1. This is my result. Or if I cross multiply, x times x minus 1 must equal to x plus 3 times 1. Now here we're going to distribute. So x squared minus x equals to x plus 3. And like I mentioned earlier, every time that you have something squared, like x squared, we have to let it equal to 0. So we're going to subtract minus x minus 3 from both sides. That way we can set the equation to 0. So this gives us x squared minus 2x minus 3 equals 0. Why? Because negative x minus x will give us a negative 2x. On the right side, it'll be set to 0. Now here, guys, we have to know how to factor. Okay, now, so how do we factor x squared minus 2x minus 3? Like I tell my students, right? The second sign, which is the sign of the constant term, determines the signs here. It's going to be the same or different. If it's negative, they're going to be different. If it was a plus, they'll be the same. Okay? Why is that? Because negative times a positive will give you the negative. So then we get the factors of 3. How can we get 3? It's only 1 times 3. And then when we subtract them, must equal 2, right? Which it does. That's why these are the factors. If you guys have a hard time factoring, guys, see, I believe I did a presentation on week 3. Go look at that presentation, and I believe it explains it like in detail of how to factor. So then, right, we said both equal to 0. So we get x equals to 3 and x equals to -1. These are my solutions. Let me go to the next slide and actually check the answers. Okay, now, so let's first try. Okay, what I do? Let's first try x equals -1. Okay. So I'm going to plug in -1 for every x. And we notice it's not going to be defined, right? Because remember I said that you cannot have a negative log. So this on the left side is not, also the -2 here will be not defined. So that's not defined. So that's not my solution. Now let's plug in the 3. Right, so we plug in 3. This will give us log of 3 on the left side. On the right side, log of 2 minus log of 6 minus log of 2. You can actually put this in the calculator, guys, if you want. Okay? And this should be the answer to both sides. But also you can do it by applying some of the logarithmic properties. For example, here, guys, right here, let's try to condense it by putting it under one log, right? But using the quotient rule, right? If you have log of 6 minus log of 2, we put them as a single log, and it'll be 6 divided by 2, which will give us log of 3 on both sides. Okay? And I believe, so that's my solution. So I believe, guys, let's do one more. So let's do example number 14. I believe this is the last one. Okay? Hopefully that way I can have time for questions here. So how do we solve this one here? This is a different rule now. If you raise, say you have the same base, right? Say you raise the base here with the log. I mean if you match the base of the log, and this becomes your exponent. So a log of a to the u, this is equal to 1. So we just bring down the u. So in other words, let me show you what I'm talking about here on this rule, because it's a little bit hard for you guys to understand, I believe. So I'm solving for x, right? So this is log of base 3 of 6x minus 2 equals 2. So my base is 3. Need to cancel the log of 3, of base 3. How do we do that? We put like a big 3, right? Now this becomes your exponent, but we do it to both sides. That's what it says here. Let the expression on both sides of the equal sign be the exponents, and the base of the logarithm be your base. If this was a 4, if it was log of base 4, then this would be a 4 on both sides, like a big 4. Okay, now by applying the rule on the left side, all we do is bring down the exponent, the 6x minus 2, and this equals to 3 squared. Now we get to simplify. That will give us 6x minus 2 equals to 9. We add 2 to both sides. So 6x equals to 11. We divide both sides by 6. So x equals to 11 over 6. Now, how can we check our work? Let's do it then. The answer for x was 11 over 6, right? So I'm going to plug it in there. So, right, so we plug it in there. The 6 is canceled, so we have log of base 3, 11 minus 2, which will give us log of 3 of 9, right? Equals 2. Now, if you put that in the calculator, this is called the change of base. But remember, guys, how do we get this, guys? What does it mean? This is how you read it. 3 to what power gives me 9? The answer is 2. But again, you can actually put this in a calculator by applying the change of base. So 2 equals 2. So we know that's my solution. And I believe I covered the most important topics for this week. And if you have any questions, put them in the chat. That way I can answer your questions. But if not, I believe that's it with my presentation, and I want to thank you for joining in. Does anybody have any questions?